All right, so starting with 13.3 today, definitions of b to the 0 power and b to the negative n. What happens when we have a negative exponent? So this next rule, this is our sixth exponent rule. And we have 0, or x to the 0 power is equal to 1. All that's saying is that anything to the 0 power is equal to 1. All right. So here we have to be careful with our parentheses and what's being applied by our exponents and all that stuff like that. We talked about that last class as well, in which anything to the 0 power is equal to 1. But when I look at this one right here, negative 4 to the 0 power, if there aren't parentheses there, then the 0 power is only being applied to the 4. So that's going to be a negative that's still going to be out front. And then 4 to the 0 power is 1. All right, so the 0 power is only applied to the 4. So that's why it's negative 1 as your final answer. That negative is still sitting out there, never affected by the 0. For this one down bottom, though, everything in the exponent or everything in the parentheses is affected by your exponent. So that would be just positive 1 because negative 4 to the 0 power with the parentheses is going to be positive 1. Anything to the 0 power is positive 1. Once you hear going back here, only thing that was applied or affected by the 0 power is that 4. So for this one, 4x to the 0 power, same thing. Only thing that's being affected by the 0 power is the x. So there's 4 times 1, which is 4. And then there's this last one, everything in your exponent, everything in the parentheses are being affected by the exponent. So your final answer is 1. All right. Any questions on that before we move to the next one? All right, that's it for the 0 power. So, negative exponent. If anything's raised to a negative exponent to make it positive, you can drop it down into your denominator. So that's what we have here in this first one. X to the negative m power. To make that m positive, bring it down, take it down to your denominator. And here we have x to the negative m power. To make it positive, we take it up to the numerator. So that gives us just x to the m. And then here, x over y to the negative m power. If you apply the negative, then you just flip the fraction that's involved. And that'll leave you with just positive m as your exponent. All right, any questions? Any questions? Erase some of these. All right. So we have c to the negative third power. We want to simplify. In other words, we want to write it without the negative exponent. You would just write 1 over c to the third power. So you take that c to the third power, bring it down to your denominator to make that exponent positive. Same thing happens here, 5 to the negative second. That'll be 1 over 5 squared. And then 5 squared is 25, so that's 1 over 25. All right, over here we have 1 over negative 3 to the negative fourth power. So those negatives have nothing to do with each other. The first thing you would do is bring your negative 3 to the fourth power down bottom. So you can have a positive exponent. And then negative 3 to the fourth power is negative 3 times negative 3 times negative 3 times negative 3. And that's going to be 81. Negative 3 times itself 4 times will give you 81. All right, questions on those three before we go to another one? All right. So the next two, looking at these two, once again emphasizing what's being affected by the exponent and what's not, depending on if you have parentheses or not. So here in this first one, the only thing that's being affected by that exponent of negative 2 is just the y. So that's why you see right here, we just drop the y down bottom. In this case, because we have parentheses, both the y and the x are affected by the negative exponent. So that's why we drop both of them down to the bottom. And then don't forget your exponent rules. This square goes to each piece. So that's why finally you have 1 over x squared, y squared. All right, questions, any questions? All right. So in the same fashion, when we talked about if it's negative in the numerator, your exponent is negative in the numerator, you take it down to your denominator. Well, if it's negative in your denominator, then you take it up to your numerator. So let me erase some of this stuff just so we can walk through it. All right. So, and that was a 2. So we have 1 over 6 to the negative second power. Once again, to make it positive, bring it up to your numerator to be just 6 squared. And that'll be 36. Okay, not a problem. Not a problem. All right, the next one, negative 3 over 5 raised to the negative third power. So we're going to apply this negative over your exponent first and flip that fraction. So it's negative 5 over 3. Now we'll cube negative 5 and 3. And then negative 5 times itself 3 times would be negative 125. Then 3 times itself 3 times would be 27. All right, any questions? All right. All right, so looking at this next one. All right, so looking at the top, we have, oh, where's my drawing? There we go. We have x squared times x to the negative 7. So don't forget, whenever you multiply your exponents, you're going to add, whenever multiplying your variables, you're going to add your exponents. So you're looking at 2 plus negative 7. And so that'll be x, red, so I'll stay red. X to the negative 5th. And then when we're dividing, you're supposed to subtract your exponents. So be careful here. This division sign is the reason why we're doing that subtraction. So you don't want to lose signs or lose translation. The reason why we have that minus sign is because of that division sign. Whenever you're dividing your variables, you subtract your exponents. So it'd be x to the negative 8th. And then to write it as a positive exponent, it's 1 over x to the 8th power. All right, any problems with that? All right, so here we have 2p to the negative 4th q to the 3rd over 5p squared q. All right, so this negative right here is going to cause us to flip the fraction. The square is still there, it's just not, it's no longer negative. Then we have 5p squared q over 2p to the 4th q to the 3rd. All right, so now this square that's out here needs to go to each piece that's in the parentheses. So that's what we have now. 5 squared, p squared squared, q squared, 2 squared, p to the negative 4th squared, and q cubed squared. Any problems? So 5 squared is 25. Whenever you raising a power to a power, that's going to be multiplication. So it's p to the 4th, q to the 2nd. 2 squared is 2. And we have negative 4 to the 2nd power, which is going to be negative 8. And then 3, or q to the 2nd power. It's going to be 6. All right. Now we can break it up. 25 over 4, p's over each other, q's over each other. And that's what we have right here. And don't forget, whenever we're dividing, we're subtracting our exponents. So that's why we have for p, 4 minus negative 8, and then for q, 2 minus 6. And don't forget, negative to negative turns positive. So this would be the result right here. 4 plus 8, which is 12. And then 2 minus 6 for our q, which is negative 4. And don't forget, we want to write this, or our final answer, without a negative exponent. So you will bring the negative, well, the q to the 4th. I would take it down bottom and write it down there with the 4. And so that would be 25p to the 12th over 4q to the 4th. All right, any questions on that one? All right, another type of problem we can see, 2 to the negative second power plus 3 to the negative, well, not negative second power, excuse me, 2 to the negative first power plus 3 to the negative first power plus 5 to the 0 power. If we rewrite this, simplified as much as possible, this negative exponent makes me rewrite that as 1 over 2. Rewrite this one as 1 over 3. And then anything to the 0 power is just 1. So we have 1/2 plus 1/3 plus 1. All right. So now, don't forget, whenever you have fractions and you want to add them, whether it's adding or subtracting, you need to find common denominators. So my LCD is going to be 6. That's the smallest number that 2 and 3 can divide into evenly. So here I'm multiplying top and bottom by 3 in order to get a fraction with the denominator 6. Multiplying top and bottom here by 2. Then multiplying top and bottom here by 6. 6 over 6 is still equal to 1. So that would be 3 over 6 plus 2 over 6 plus 6 over 6, which will ultimately give me 11 over 6. All right, questions? Any questions? All right, everybody good before we go to the next one? All right, so try those out. Remember I mentioned before, when it comes to these exponent rules, the way to get comfortable with them is by doing them repeatedly. So make sure you take that time out to do so, get that practice in. And if you have any questions on any of them, make sure you bring them to class so we can talk about them, knock them out. All right. Let's look at scientific notation. I believe that's all that is in 13.4. Yep. That's all we're going to do today. So scientific notation. So you use scientific notation when you have very, very, very large numbers or very, very, very small numbers. Numbers normally used in, scientific situations. So your number will fit into this form, wherein it will be a times 10 to the nth power. So a is going to be in between 1 and 10. It can be 1, but it cannot be 10. And then n is an integer. That means n will not be a fraction or a decimal. So when you look at this exponent, n will not be a fraction or decimal. So in the red, we have a few examples of what we mean by scientific notation. 1.23 times 10 to the 5th power. See, the 1.23 is in between 1 and 10. And then my exponent is not a fractional decimal, just a solid number for us. And then 8.7 times 10 to the negative 11th power. Once again, we have a number right here in front of the multiplication sign, 8.7, which is in between 1 and 10. And then my exponent is negative 11. So in order to be in scientific notation, it has to fit that criteria. A has to be in between 1 and 10, and then your exponent cannot be a fractional decimal. It can be negative or positive, but it's not going to be a fractional decimal form. All right. All right. So first exercise is write in scientific notation or write using scientific notation. So the first thing you want to do is find the decimal. And if you don't see one, they assume you know it's to the right of the rightmost digit. And you move the decimal as many places as it takes to create a number that's in between 1 and 10. So when you look at 53, 5.3 will be a number between 1 and 10. If you put the decimal behind the 3, that's going to be 53. So that would be too large. And then if you took the decimal past the 5, then that would be 0.53, which would be too small. So we want to get our decimal right here in between the 5 and 3. 5.3 will give us that number. So I take it and I move 1, 2, 3, 4. I went 4 to the left. So that's going to be 5.3 times 10 to the 4th power. All right. So this next one, 0.000079. So the decimal, I see my decimal and I take it and move it 6 spaces to the right because that's going to give me 7.9, which is a number that's in between 0 and 1 and 10, excuse me. So it'll be 7.9. This time I'm going right with my decimal. 10 to the negative 6. So notice before I had a large number and my exponent was positive, I took my decimal to the left. This time I have a very, very small number, took my decimal to the right, and I had to use a negative for that exponent. All right, so here, same type of deal. Take my decimal. If you don't see it, once again, they assume you know to the right of the rightmost decimal or digit. And so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, because we want to create that number. That's between 1 and 10, and that'll be 1.9, 1.5 for us. So it's 1.5 times 10 to the ninth. Once again, it was a very large number. It lets us know that our value should be positive exponent. Multiplying 1.5 times 10 to the ninth will take us back here. All right, so last one, we got 0.0000008571. Decimals right here, move it 1, 2, 3, 4, 5, 6, 7 to the right. So it's going to be 8.571 times 10 to the negative 7. Once again, we had this small number, and this negative 7 as an exponent represents that. All right, any questions before we go the other way with it? All right. So now we're going to go in the opposite direction. We're going to write in standard form. So in the first one, we have 1.67 times 10 to the fifth power. So we're going to reverse the process. If I have a positive exponent, that means my number should be very large. So in order to get that, I'm going to have to take my decimal to the right. 5 spots, 1, 2, 3, 4, 5. And if I'm missing spots, I need zeros as placeholders. That's 167,000. Next one. This time is a negative exponent, so I need to take it in the other direction. I did do 5 to the right. So this time I'm going 3 to the left. 1, 2, 3. Once again, using placeholders for the spots that were not there. So my final answer, 0.00231. All right, any questions? All right. All right, are we good with going in the opposite direction before we look at one more thing? Are we good? All right, so let me go ahead and erase some of this stuff so we can walk through it. All right, so we have 8.7 times 10 to the fourth times 2.5 times 10 to the negative 12. and they want us to multiply or divide as indicated. So the first thing we want to do is recognize that we have kind of like terms, I guess you would say, and we want to multiply those together. So we have 8.7 times the 2.5, and we want to multiply the 10 to the 4th and the 10 to the 12th. Negative 12, I should say. All right. Multiplying these two numbers together will give us 21.75. Multiplying these together will give us 10 to the negative 8. Don't forget, we need to add the exponents. So that's how you got negative 8 right here. Now, this answer is not in scientific notation. Because remember that 21.75 is supposed to be in between 1 and 10. So what we're going to do is move our decimal one place to the left. So that'd be 2.175. That's what I have right here. But to give an account for that, you also have to have this 10 to the 1 because you move one to the right, but the one to the left. So that's 10 to the first power. So we convert it to scientific notation. So 21.75 is 2.175 times 10 to the first power.
I have a question. I missed where we got the 10 to the first power from.
Right here. So I move my decimal 1 to the left to turn it into 2.1. Okay. So,
okay.
Yep. So just making sure everybody's with us. So we had 21.75, but that's not in scientific notation. Remember that number has to be in between 1 and 10. So I'm going to move my decimal one spot to the left to turn it to 2.175. But if I move it to the spot to the left one spot, then I have to give an account for that. Not give an account for it with that 10 to the first power. All right. So make sure we're okay with that. And now to finish off the problem, you go ahead and combine these two, 10 to the first power times 10 to the negative 8. Once again, you have to add your exponents. So the final answer is going to be 2.175 times 10 to the negative 7th. All right, make sure we're okay. All right. So I think this is the last one. Yep, before the section ends. So now we're looking at 4.25 times 10 to the 13th power over 8.5 times 10 to the negative second. All right, so we're going to break this up. 4.25 over 8.5, 10 to the 13th over 10 to the negative second. All right, so here we need to subtract the exponents. Don't forget, just follow our same exponent rules. 13 minus negative 2, which is 15. All right. Erase some of this stuff. All right, so now we have 0.5. But remember, this number has to be in between 0 and 1. So to make it a number that's in between 0 and 1, we can move the decimal to the right one. That'll turn it to 5. And then that move of the decimal to the right gives us the exponent of 10 to the negative first power. So this turns into all of that. And your 10 to the 15th is still right here. All right. And now add your exponents. Negative 1 and 15 will give you 14. And that will be your final answer. 5 times 10 to the 14th. All right. Questions? Any questions? All right. So we okay? So some questions may, show up after you try these problems out, and I understand that. So if some pop up, then feel free to let me know, and we can go over them, knock them out. But are we good for right now as far as those two sections are concerned? That's 13.3 and 13.4. All right. Okay, so we'll pause right here. Next class, I'll open up the floor, see if anybody have any questions first, and then we'll keep on moving. All right, so you guys have a good one. Be safe, and I will see you on Friday. All right, I got everything. All right, everybody take care.